What?
500 cucumbers in 500 cucumbers in 2 hours. Why did I write that as a fraction?
Because it's a ratio.
Yeah, it's a ratio, also known as a rate. So we're going to get into the habit of writing these as fractions. It helps us keep track of the fact that it is a rate, as well as what are the units associated with it. What I want to do before we get to the questions, I want to find something called the unit rate. The unit rate is just the reduced version of this fraction, so that the bottom is a 1. So instead of 500 cucumbers in 2 hours, I want to express it as the reduced version, which would be 250 cucumbers per hour. You see, I made the bottom just 1 hour. That is a unit rate. Your speedometer gives unit rates. Okay? So, 250 cucumbers per hour. And then it says Margot reduced her rate by half because she got tired. So half of that would be
125.
125 cucumbers per hour. Then it said, how long will it take to get to 2,000 cucumbers? How long will it take her at this rate to pick 2,000 cucumbers? Now, this is not a distance, rate, time problem. However, it's the same concept. So if I remind you of the DIRT formula, distance equals rate times time, we're not finding a distance, but we are, however, finding a total that can be found by multiplying the rate times the time associated with the rate. Now, for us, 125, that's my rate. Okay? So, I've got 125. I'm looking for a total of 2,000 cucumbers. The only thing left to find is time. Now, was there a question or some words involved here that told me I was going to be looking for time?
How long?
How long? Okay, see how the question points you to what type of answer you're looking for. So you have to know that the total can be found by the rate times the time. And then we know some simple algebra. I hope you remember some simple algebra. How do you get rid of multiplication? We're going to divide by 125. Okay? So we're going to get that t equals... What did you guys get? That was the one that most of you wrote down, right? And I checked that you did, I guess. 16 hours. Now look at the units. It had to be hours because I'm talking about time. All right? Can I show you the moped way to solve that problem? Why do I call it the moped way? I know that's what you're all thinking. Yes. But it will still get you to the same place. Okay? It will still get you to the right answer. So, what we have here, the formula, we could call that like the airplane method. Because it's faster. Okay? But it doesn't mean you can't get there on foot or on moped. So here's what I'm going to do. I'm going to make a table of time and cucumbers. Okay? First concept, if none of the receptacles work. So you need a sharpened pencil. Maybe we should plug it in up here. Huh? Okay. If no time has passed, how many cucumbers have been picked? 0. Okay? In order for an event to take place, time has to pass. That's logical, although it will blow your mind if you think about it too much. At her new rate, after 1 hour, how many cucumbers will she have picked?
A lot.
Look at what her rate is. It says 125 every hour. So after 1 hour, 125. After 2 hours, 125 more, or 250. After 3 hours, 125 more, or 375. And so what I hope you see is that you could do this all the way until you got to 2,000 cucumbers.
That'd be a lot of effort, though.
Well, there's a rule, and it's not official, but I like to think it's pretty applicable. Fast, correct, and easy. Anytime you're doing a math problem or any life problem, pick two of those.
Correct.
Pick two of those.
Oh, fast.
You cannot have all three. You cannot have all three.
The C. Fast and
Easy and fast.
Easy and fast is usually not going to be correct.
Fast and correct.
Fast and correct will be hard.
Easy and correct.
It'll be slow.
Is there the right answer?
You're thinking
They're all right.
Except fast and easy.
Fast and easy are generally not going to be correct. Think about your relationship problems. Boys, just check out for a second. Girl drama, okay? I'm just trying to prepare myself for it with 4 daughters. Whatever the solution is, it's if you choose the fast, correct one, I'm just not going to call her back. It's not going to be easy. Or the fast and easy thing, right? Just unfriend her.
Oh,
Probably not the right thing to do.
no.
So, I'm being serious here, okay? Fast, easy, and correct. When it comes to math, you get two. You can pick any two you want. If you want the fast and correct one, guys, fast and correct, it won't be easy unless you study and you put the work in, okay? All right. All that to say this. The moped can still get you the right answer. It'll just take a longer time. Till you get all the way to 2,000, and it took you 16 hours. Okay. All right, maybe we won't post that one since I was recording that. Oh, well, maybe you guys will remember it.
Can they
Better.
hear us? Yeah. Is there a microphone in there?
All right.
No, have you never watched a video before? No.
So, number one, the bus labored up the mountain at 40 yards per minute. What does 40 yards per minute represent? Starts with an R. A rate, or ratio. So that's why I wrote it as a fraction. It's completely okay to keep saying ratio, Chloe, because it's correct. Okay, 40 yards per minute. 2,800 yards to the top. What does that represent? The 2,800 yards. So that's our distance. That's our rate. What's missing? Look at the question. How long would it take? Time is what's missing. So rate times time equals distance. Look, guys, 40t equals 2,800.
It's 50.
How do we solve this equation, right? This is why we start with these things. Then we can use them to solve problems. I'm multiplying by 40 here, so I'm going to divide to cancel that out. We're going to get that t equals 70 minutes. You're what? Okay. Number 3 is almost identical. The machine bottled 8,000 bottles in 4 hours. Okay, what is that called? 8,000 bottles in 4 hours? A rate. How would I make it a unit rate? I want 1 on the bottom. How do I do that, Carter? I want 1 on the bottom. What's 8,000 divided by 4? What's 8 divided by 4? And then 3 zeros. 2,000 bottles per hour. I want the unit rate, so that's where I get it. Then it says if the rate is doubled. So then I want to double the rate. So what would my doubled rate be? If the initial one was 2,000 bottles, it would be 4,000 bottles per hour. Okay? And they're asking you, how long would it take? So I'm looking for time to get 40,000 bottles. Okay? And I'm going to run out of space on my page. But this is not a distance, is it? 40,000 bottles is not a distance. However, I need you to remember the concept that distance is equal to rate times time. Therefore, in the same kind of context, we can find a total by multiplying the rate and the time. Okay? So, really short on space here. 40,000 bottles is my total. My rate is... Oh, did I forget to double the rate? I must have forgot to do that in the first period. Oh, well. Our rate is 4,000 bottles per hour, and then I'm looking for the time value. So 40,000 is equal to 4,000 times t. What does t have to be? $40,000 is equal to 4,000 times what? 10. 10, what are the units? It's hours. I'm not going to show you the moped method there. I think you guys get the idea from the previous one, okay? All right, number 12. Number 12. Radius equals 10 centimeters. We want to find the circumference. We want to be able to find the area. Are there formulas we're supposed to know for this? Circumference is equal to pi d. Area is equal to pi times r squared. Okay? Pi d and r squared. So all I've got to do is plug in the values that are associated with that. C equals pi times d in this case. Well, I don't know what d is, but I can take my radius and do what to find it? Do what? Nope. It's 20. It's double the radius. So 20 pi is my exact answer, or 62.8 centimeters. The area is just pi times r squared. Well, it tells you straight up r is 10. What do you do first? Times pi or squared? I do the 10 times 10 first because exponents comes before multiplication. So that's going to turn into 100 pi, which is estimated at 314 centimeters squared. Anybody getting these? Saul Berkeley's. But I don't know how many of you got to these problems. There's a lot of chatter or secret operations behind a textbook that's not suspicious at all. So, number 16. Number 16 is a proportion. We solve proportions pretty much the same way every time. 5/12 and 5/3. We're setting that equal to 5/2 over k. I'm going to really emphasize this line that's making my fraction here. But the one thing, this was on the quiz, we have to cross multiply. So we get 5/12 k equals. Now how do you multiply 5/2 times 5/3? Top times the top, bottom times the bottom. We still have a proportion, so we're going to do it again. We're going to get 30k because 5k times 6, and then 12 times 25 is 300. Then we're going to divide both sides by 30 because that's the opposite operation that will help us solve for k, and we get 10. 16. 19 was something from last week. 3x plus 6 equals 28. There was a video. It was lesson 61. And to jog your memory, I'm simply going to ask, how many steps does it take to solve number 19? Two. It's basically, okay, don't hear me say every time, but it's basically order of operations flipped around. So instead of doing parentheses, exponents, multiplication first, we do addition and subtraction first. Because we want to undo the operations. We want to cancel the plus 6. So we're going to subtract 6 on both sides of the equation. Now, at least one student in first period was confused when I kept saying side of the equation. What do you mean side of the equation? Well, an equation is divided into a left side and a right side, and it is the equal sign that is the dividing line. So, we subtracted over here to cancel that or remove it, so to speak, to the other side. And then we have one thing left to do. Now, you heard me say it was like order of operations backwards. Since we added or subtracted to begin with, now we would look at multiplication and division. It's division that helps us in this case. And don't feel like you have to do anything to that answer. 22/3 is perfectly acceptable and correct. Okay. Are y'all doing okay on these? All right. 29. Now, I don't know if I have as many people in here who try to do this without writing it down. But there are some people who are struggling in first period because they won't write anything down. They try to do it all in their heads. And it's becoming a problem for them at this point. So, you need to write it down because these steps are going to grow. X equals 16, y equals 2, z equals 1/4. So this is called evaluation. All it means is to find the value of this expression with these numbers plugged in. Okay? So everywhere I see an X, I'm going to replace it with a 16. Everywhere I see a Y, I'm going to replace it with a 2. Everywhere I see a Z, I'll replace it with a 1/4. Okay? All right. So, what do I do first? The multiplication first. I can do these all kind of separately because they all come before addition and subtraction, right? So 16 times 2, take a quarter of that. We should get 8. 16 squared is 256. What does this mean? It means square root. It means find a number that can be raised to the second power to get 16. It's 4. And then we're going to subtract 16. So I'm going to write down a couple things about square roots over there. But you have to do this in order from left to right. You can't do subtraction first. You can't pick one to do it. You have to do it in order. So we're going to get, 264 there? Plus 4, 268, minus 16, 252. Now, a couple of side notes over here on square roots. Okay? Those are the same thing. The 2 is understood. But the fact that that number can change means you'd be looking for something different here. Okay, so I'd be looking for a cube root here. I'd be looking for a fourth root here. But if I'm just looking for the second or square root, they're usually not going to write that number, okay? Second thing to remember. 3 squared equals 9, right? So, the square root of 9 is equal to 3. 4 squared equals 16. So, the square root of 16 is equal to 4. You see, they just end up showing you the same property in opposite ways. Or said another way, what is addition to subtraction? How are they related?
They're opposite.
They're opposites. Well, guess what? Squared and square root are opposites of each other. Okay, so that's something to remember as you get closer to algebra whole, which is different than algebra half, I guess. Okay. Any questions or anything you guys didn't get as I went over those? Let's take a brief look at lesson 64. Semicircles, or as I like to think of, hemicircles, because they're basically half. Okay? Got a couple definitions. An arc length. How many of you guys like stuffed crust pizza? You ever wonder, how do they get the cheese in there? It comes out of a tube, squirt it? Because that's what you made it seem like.
I don't know.
Okay.
Then, they put a little cheese stick in it and they wrap it with dough and they make it.
That's what I think. They got like a little string cheese, and they. You ever thought, how much does it take?
A place that makes stuff.
I don't know if you guys are old enough, but stuffed crust is probably older than you. I remember the commercials that would talk about people who eat their pizza crust first.
Who does that?
That's the best way to eat pizza.
Apparently he does. All right. So, here's the thing. We have something called arc length. Arc length is a portion of the circumference, okay? So, suppose I had a start and stop point here. It's not the entire circumference, but rather only a section, okay? And pizza is going to be the best analogy I have for this, right? It's only like the crust and not the whole thing, right? But just part of the entire circumference, right? It's a portion of circumference, okay? So one way to do it would be to find the entire circumference and divide it by whatever factor you needed. The other thing, and this is not in your book, so you don't have to know it for this lesson, but I'm going to teach you that because it's related. A sector is simply a piece of the area. A piece, the area of the circle. Okay? It's not the whole area, but it's just part of it. Okay? So, we have some formulas that I'm going to remind you of. The circumference is pi times d. The area is pi times r squared. How are we going to be expected to use these to solve a problem? Well, let's think about a basketball court. I feel like one or two people might be interested in that. And okay, so does anybody happen to know what the measurements are here? What the foul line's what, 15 feet? And how wide is the lane? Let's say 12. Or we'll go with 10. We'll go with 10. We'll go with 10. Okay? I think it's more than 7. And you wanted to do this at your house. You wanted to put this on the concrete driveway at your house. You wanted to, instead of paint it, maybe you're going to use like tape or something, right? How much tape is required for this border, okay? How much tape would be required for this border? And then how much paint would be required to fill it in? How much filler paint? Well, I mean, if you wanted to do it and you didn't want to waste a whole bunch of money or paint, because you see resources are limited and you can't just buy like a whole bunch and use what you need. Well, that costs money. A whole lot extra money in some cases. So you want to be able to buy the right amount. Do what? How much? 74?
I'm sorry, 71.
71? How'd you get 71?
10 times 3.14. Oh wait.
Tell you what.
I forgot the.
Okay. Let's do the easy part first. The straight lines. That would be easy, right? We would just add that up. 15 plus 15 plus 10. I'm going to put an A over here. And that's going to stand for the arc. Okay? So, let's see, that's 30 and 40. I have 40 plus whatever A is. And we're going to call this perimeter, because that's a perimeter question. 40 plus A. But what is A? A is an arc that covers half the circle. Well, how big is the circle? What measurements do we use for circles? You got two choices.
This side times this, plus this side plus this side.
For circles?
Oh, for circles?
For circles. This one, right?
Yeah.
What is that called?
Radius.
Radius. What is it equal for this circle?
5.
How do you know that?
Is
The 10 is right over here. 10 is my diameter. Oh, that's cool. Okay. So if 10 is the diameter, radius is 5, then the arc would be half the circumference. And the circumference would be 10 pi. So if we divide that by 2, we're going to get 5 pi, or roughly 15.7. 40 plus 15.7 is 55.7 feet. We might have to save the paint for next time. But my gist, I think, is clear. We do what we need to for the whole circle, and then we just separate it. We divide it into 2 in this case. And that's what most of your problems will be like for this lesson, okay? So please don't miss what I showed you. The circumference formula is one you should know or memorize so that you do know. And then here we're just finding half the circumference to add it on to the rest.